have a seesaw like this, and let's say we have a ball in the middle. This is a ball in the middle, and let's have someone on the right, and let's also have someone on the left. So I want you to apply the principle that I just told you in the previous slide in this case. Now, what did I say? If we were to add, or I want you to think about a situation, remember it is balanced like this. We have the ball in the middle, we have a lady on the left and a lady on the right. This one with white shirt on the left, this one on the right. Now I want you to explain to me what will happen if we add another person close to this lady here that is on the left hand side. What will happen? You are more than welcome to pause the video and think about it. What will happen if we add someone here on the left hand side? And remember, whatever that is on the left hand side, it correlates with the reactants. If we assume that this is an equation, and whatever that is on the right hand side, it correlates with the product. So in this case, we assume that, let's assume we add more on the reactant. How will this seesaw tilt? So let's add a person. We added a person. Obviously it can't remain balanced like this when we added someone. What will happen when we add it? Will the system behave like number one, or will it behave like number two? If we add more on the reactant part, you can see that it can't behave like number one. The system will behave like number two, right? I'm happy if you pause the video and you realize that you got the same response like the one that I'm giving you now. So when the system behaves like number two, is because more are on the left hand side, then it will tilt. Even this ball will go this side. It will behave like this one, number two here, meaning that the ball will be close to this girl, and when we apply Le Chateliers will come, and Le Chateliers principle will come and do what? Or how will it be applicable? Will come and favor the forward reaction, because it will have to roll the ball to the right so that it will restore the system. Now, rolling the ball to the right, it simply means that we are favoring the forward reaction, and whatever that is on the right must increase, whatever that is on the left must decrease. So in this case, the ball will be rolling from the reactant going to the product, meaning that more product are going to be formed, whereas less reactant, or the reactant is going to be decreased. In other words, the reactant going to decrease, then product increases. So let's go back here and rewrite this nicely. We said if we add another person here, what will happen? The system will tilt like this, then even the ball will be here on the left. That's what will happen when we add someone on the reactant part. So Le Chateliers, we said, will come and do what? We apply Le Chateliers principle to come and restore the disturbance, meaning that Le Chateliers principle will shift this ball to the right. When we shift this ball to the right, it simply means that whatever that is on the right must increase, whatever that is on the left must decrease. So let's do that. Let's apply Le Chateliers principle to solve this mess. When we apply Le Chateliers, which reaction are we favoring? The reverse one or the forward one? Remember, from reactant going to product, we are from the left hand side going to the right, it's forward. But going from the product going to the reactant, it's called the reverse. It's more like going from right hand side going to the left hand side, it's reverse. So in this case, since we are from the reactant to the product, it's more like we are from the left hand side going to the right hand side. So this is what we call forward. So in this case, we are going to favor forward reaction to restore the system, and as such we will favor the forward reaction. That's why I indicated it with arrow here. And doing so, whatever that is on the right, if we shift the ball to the right, whatever that is on the right must increases, whatever that is on the left must decreases. Let us show this increment and decrement, and obviously we are going to favor the forward reaction. When you favor the forward reaction, whatever that is on the right will increase. Can you see now? We have increment. The lady now gain some sort of weight to demonstrate the increment, these two decreases now, and then the system is at a certain equilibrium again. So basically, that's how we apply these seesaw rules, or that's how Le Chatelier's principle in general works. So I want you to look at this example here, or to use this seesaw example to answer a question now given this reaction. I want you to relate this reaction with the example that is given. Let me show you in a few. Now I want you to look at this example again now. Let's now assume this time around that the system is balanced when we have two people on the left and one individual on the right. So now let's assume it's balanced. We're about to disturb the system again, right? I want you to assume that this nitrogen is represented by this lady with white shirt, and then this hydrogen is represented by this lady here. Then this NH3 is represented by this lady alone. I want you to assume that it is balanced. As you can see, the seesaw is balanced, right? And even this equation is balanced like this. I want you to take note now to say, this time around, what will happen? Remember, nitrogen is this lady, hydrogen is this one, NH3 is this one. Now, let's say, for argument's sake, we ask a question to say, what will happen? We're about to disturb equilibrium now. What will happen what happen when more nitrogen is added to the system? Now, look at it. Which reaction is favored, reverse or forward? Now, look at it in this way. If we add, remember nitrogen, it's N2, is represented by this lady. Ask yourself to say, what will happen if now more on this lady has been increased? For example, just think about a situation whereby maybe you gave this lady a heavy object, right? If you gave her a heavy object, we add, it's more like we're adding more onto her. When we add more onto her, the system cannot remain as it is. It will have to tilt. So ask yourself, how is it going to tilt, and how is it going to look like? So if you check it out, it will tilt like this, right? Because more on this lady has been added. So when it tilts like this, we can now say the system has been disturbed, and we have to apply which principle? Le Chatelier's principle, to come and do what? To come and solve the problem. So when it tilts like this, how will Le Chateliers come and rectify this mess? Le Chateliers will come and favor which reaction, forward reaction or reverse reaction. The Le Chateliers will come and shift the ball to the right, to solve this problem or this disturbance. Shifting the ball to the right or rolling the ball to the right, it simply means that we are favoring which one? The forward reaction. And when we favor the forward reaction, whatever that is on the right, because we are shifting from left to right, wherever that we are going must increase, and wherever that we are coming from must go down or decrease. Simply means that we shift the ball to the right, or the equilibrium will shift to the right, or the forward direction will be favored, so to say. We can say the forward direction is going to be favored. Whatever that is on the right hand side must increase, meaning that the products must increase, or more products will be formed. Then in terms of the reactants must decrease, meaning that in this equation, if we add more of NH2, the system will tilt like this, meaning that we will favor forward reaction, and NH2 will increase, NH3, so to say, NH3 will increase. What about H2? Must decrease. What about N2? Must decrease, because whatever that is on the left, if we shift the ball to the right or favor the forward, whatever that is on the left must go down or decrease. Whatever that is on the right, if we are shifting towards the right, because we are favoring the right, the one that is at the right, meaning that it must increase. That's why NH3 increases like that. So we favor the forward direction. That's why I indicated with the arrow here, and then the ball will shift to the right, favoring the forward reaction. So at the end of the day, the forward reaction will be favored. Whatever that is on the right will increase. That's why even this lady now, if you check her well, she gains some sort of weight. She increases. NH3 will increase. That's why I even indicate with this arrow to say it will go up. What about the H2 hydrogen will decrease, arrow down. What about nitrogen? Nitrogen decreases. As you can see, this lady, their their concentration or amount or number of mole should go down or decrease like that. Now, I want us to continue, but this time around focus more on the reactant, on the reaction, not longer on the seesaw. However, I will even give you the seesaw again in this case to help you answer this kind of question. Now, let's look at it in this way. We have A reacting with B to give us AB. The question says, what happens if more AB is added to the system? I want you to think about the seesaw that we just talked about. If we add more on the product, remember, assume that this is a seesaw that is balanced, right? If you add more of AB, the system will tilt. And by now you must know how will it tilt. Let me show you now how will it tilt. It will tilt like this, right? When it tilts like this, the ball will be close to the boy here, will be on the right, right? Which reaction will be favored? Which reaction will be favored? We are simply saying how will the Chatelier's principle is going to be applicable to resolve the disturbance. So when you add AB, you disturb the system, the ball roll close to the boy. What will happen when you apply Le Chatelier's principle? When we call out for Le Chatelier's principle will come and shift the ball to the left, meaning that we are going to favor the reverse reaction. And when we favor the reverse reaction, whatever that is on the left must increase, whatever that is on the right must decrease. So in this case, AB will decrease while B increases and A increases. So now, from there, I want us to look at another example. A and B we said increase, and then AB decreases like that. So I want you to look at another example. Let's say we have A and B again reacting to give us AB, but this time around we are no longer focusing on what if happen when more AB are added. This time around, let's change the question and says what happen if more B is added to the system. Look at this reaction, A reacting with B to give us AB. This time around, let's change the question and says now, what happens if more AB is added? Where is B? More B is added. There is B. We have B here on the reactant, right? If we add more of B, will the system tilt like number 1 or will the system tilt like number 2? Pause the video and try to answer that question. And also tell me which reaction is going to be favored. Try to pause the video and do that quickly. Now, if we add more on B, the system cannot tilt like number 1. Why? Because remember, this reactant are more like the lady that is on the left. This AB are more like this guy that is on the right. So if you check it well, when you add more on B, there will be more mass on B, right? Or more of B will simply means that the system is going to tilt like number 2 here, right? If you manage to grasp this concept, this simply means that this kind of question will never be difficult to you if you're able to tell what will happen when you add more of B like this one. So the system will tilt like number 2 in this case, and when it tilts like number 2, the ball will be close to this girl. Then how do we tell if the reaction is going to be forward or reverse? We call Le Chatelier's principle or we apply Le Chatelier's principle. And how do we apply Le Chatelier's principle? We shift the ball where? We shift the ball to the right. When we shift the ball to the right, it simply means that whatever that is on the right must do what? Increase. Whatever that is on the left must do what? Decreases. So what does this mean as far as this equation is concerned? It simply means that if we add more of B, we are going to shift the ball to the right, and AB must increases while B decreases and A decreases, like that. So the forward reaction is going to be favored. So let's change the question again, and now I have this question in this manner. So I want you to forget about everything or about this question and the second question, and now focus on this question here. I want you to focus now on this equation, and please feel free to pause the video and try to answer this last question out. What happens if we reduce B? So I want you to assume that we have A, B to give us AB. Forgot about this arrow for now, because we are now focusing on this question, which says what happens if we reduce B. Let's look at B. Where is B? B is here. So if we reduce B, it simply means that we are subtracting something from B. And you know that if AB to give us AB is balanced, you know that if we subtract B or sum of B, it simply means that we are going to disturb the system. So I want you to tell me which system is going to be applicable here, or which seesaw is going to be applicable, seesaw number 1 or seesaw number 2, if we remove sum of B. So if we subtract or remove sum of B, if you check it well, you will realize that the system cannot tilt like like number 2. Why? Because when we remove more of B, this one will be heavy, and when it's heavy, it will go down. So this simply means that the seesaw that is going to be applicable in this case, it's seesaw number 1. Seesaw number 2 cannot be applicable. And when we have seesaw number 1, the ball will be closer to this ball. Now, who do we call to come and rescue us or come and restore the system back to where it was? We apply Le Chatelier's principle. Then Le Chatelier's principle, how is it going to be applicable? Le Chatelier's principle will come and shift the ball to the left. What does that mean? It simply means that we are favoring which reaction? The reverse reaction, because we are moving from product to the reactant. We are moving from right to the left. It simply means that doing so, we are favoring the reverse reaction. And when we favor the reverse reaction or move from right to the left, it simply means that whatever that is favored or whatever that is on the left hand side must increase. Whatever that is on the right side must decrease. So in this case, it simply means that if we remove sum of B, we are favoring the reverse reaction. When we favor the reverse reaction, B must go up, A must go up, whereas AB must go down. It simply means that removing some or disturbing the equilibrium system by removing some of B, we are favoring the reverse reaction, and as such, A must increases, B must increases, whereas AB must decreases or must have decreased. So now, ladies and gents, I want us now to look at previous exam papers. We are only going to focus on question that has to do with what we have just talked about now. So let's look at this previous question paper. There is the question. We are going to focus on question 6.3 only and ignore the rest of the question. And I will also bring the seesaw here so that we can know which seesaw is it going to be applicable. So I brought seesaw disturbance number 2 and seesaw disturbance number 1. So this seesaw disturbance, I just brought them so that they can help you when you answer this kind of question. So I want you to look at it in this way, ladies and gents. We have 2p plus q2 to give us 2pq. All are in gaseous form, or they are all gases. Now, the first question obviously it says define the term chemical equilibrium. And we know that from the word equilibrium, we know equi mean, or you should know by now that equi simply means that equal, right? Or it's derived from the word equal. What is it that is equal as far as chemical equilibrium is concerned? Is the rate of what? Of forward and the rate of what? Reverse, meaning that when you talk about the chemical equilibrium, we're just talking about a situation whereby the rate of forward reaction is equal to the rate of the reverse reaction, like that. However, here I want you to focus much on question 6.3, whereby it says more of is now added to the reaction mixer at constant temperature. And guys, know that at constant temperature, Kc remains the same. But in this case, we are not talking about the Kc, because 6.3.1 is talking about the yield of PQ. So how will each of the following be affected? Choose only increase, decrease, or remains the same, right? The yield of PQ. So I want you to do like this. More Q2 is now added to the reaction. Let us use the seesaw to assist us. Where is Q2? Q2, is it on the reactant side or on the product side? If you check, Q2 is on the reactant side, ladies and gents. So here is Q2. So what will happen if we add more on Q2? Which seesaw disturbance is going to be applicable here? If we add more of Q2, the seesaw disturbance that will correlate with this situation, is it seesaw number 2 or seesaw number 1? If you check it out, pause the video and try to answer this question quickly. If you check it out, if we add more of Q2, they will be heavy here on the reactant. And when it's heavy on the reactant, it will tilt like number 2, because it will go down here on the reactant like this one, meaning that the seesaw that is going to help us in this case, it's seesaw number 2. Now, what does seesaw number 2 mean as far as Le Chateliers is concerned? How will Le Chateliers behave when as far as seesaw number 2 is concerned? Le Chateliers, remember, the ball will be close to the girl this time around because it tilted to the left like this. Le Chateliers will come and shift the ball to the right. When we shift the ball to the right, we are favoring which reaction, reverse or forward? We are favoring forward reaction. So when we favor forward reaction, what will happen now to whatever that is on the right hand side? If we shift from left to right favoring the forward reaction, ladies and gents, whatever that is favored or that is on the right must increases. So in this case, if we shift to the right, whatever that is on the right, which is PQ, must go up or increases. What about Q2? Decreases. What about P2? Decreases. So in this case, the ball will be shifted to the right favoring the forward direction, and whatever that is on the right will increase, whatever that is on the left will decrease. So in this case, PQ will increase, whereas Q2 decrease and P decreases. Now let's go to the question 6.3.1. The yield of PQ. Where is PQ? PQ is here on the product, and we mentioned to say the product will increase. So this simply means that the yield of PQ will increase. What about now P? P is on the reactant. Whatever that is on the reactant must go down or decreases. So this simply means that the number of what? Of P, or the number of mole of P, will have no choice other than being decreases like that. So now let's continue and have another question, but our main focus will be on this kind of question that has to do with this disturbance that we have just talked about. Now I want you to look at this, ladies and gents. We have now the reaction CS2 in gases, 3Cl2 in gases, S2Cl2 in gases, CCl4 obviously in also gases. We are told delta H is less than 0, but it's fine. We are not going to dwell much onto that. We are going to jump straight to 6.4 or question 6.4. Ladies and gents, please feel free to pause the video and try to answer this question, then see how I also answer it. Now, the question says more S2Cl2 is added to the equilibrium mixer at a constant temperature and pressure. Remember, at constant temperature, the value of Kc remains the same at constant temperature. That's the tricky part. Now, let's look at it. If I want you to apply the seesaw, let's assume that this is balanced, and then we are told that S2Cl2 is now added. Where is S2Cl2? This is not S2Cl2. This is not S2Cl2. This is S2Cl2. It's on the product, right? It simply means that if we add more of S2Cl2, how will our seesaw tilt? I want you to think about what we did on the previous slide and help me, guide me as to how will now the seesaw tilt. So if you check it out, the seesaw will tilt like what? Will it tilt like number 1 or will it tilt like number 2? I want you to pause the video and try to work it out. If we add more of S2Cl2, they will be heavy, or it will be heavy here on the product, meaning that the only seesaw disturbance that correlate with this situation, it's seesaw number 1, ladies and gents, meaning that if it's seesaw number 1, the ball will be close to this boy here, right, that has a blue t-shirt or shirt. Now what will happen now? How are we going to apply the Chateliers? To apply the Chateliers, we come and shift the ball to the left, favoring which reaction? The reverse reaction. And when we shift the ball from right going to the left, wherever that we are going, it simply means that whatever that is on the left must increases, whatever that is on the right must decreases. So this simply means that in this case, if we add more of S2Cl2, we are favoring the reverse reaction, meaning that whatever that is on the reactant side must increase. This simply means that in this case, CS2 increase, Cl2 increases, S2Cl2 decreases, CCl4 decreases. That's what will happen. So the first question says the concentration of CCl4. Where is CCl4? CCl4 is on the product, and I mentioned to say in this case, whatever that is on the product must decrease. It simply means that same applies to CCl4, it will go down, it must decreases. What about the number of mole of Cl2? We come and check from the equation. Where is Cl2? We don't have Cl2 here. We don't have Cl2 only here. We have S2Cl4. We have Cl2 here. In other words, Cl2 is on the reactant, meaning that whatever that is on the reactant, based on what we talk about here, as far as this seesaw disturbance number 1 is concerned, whatever that is on the reactant side must do what? Increases. Same applies to this one, 6.4.2. It simply means that the number of mole of Cl2 must increases. What about the value of equilibrium constant? The value of equilibrium constant will remain as it is. Why? Because we are talking about a situation that is happening at a constant temperature, and at constant temperature the equilibrium constant remains the same. So ladies and gents, thank you so much for watching this video. If you find this video useful, try by all means to give me thumb up, and thank you so much.